Hello everyone. So in this video, let us talk about the first 5 problems from the latest AtCoder beginner contest 245. So let's start. The first problem is easy. It says that one day Takahashi got up at exactly B minutes past A o'clock, and it is a 24-hour clock. And Aoki will get up at exactly D minutes and 1 second past C o'clock. Now, if Takahashi got earlier, then you have to print Takahashi, or else you have to print Aoki. Now, how you can do that? Now, it's generally just the best way to convert everything into seconds, whatever time is there. And if like Takahashi gets up earlier means that this time is smaller than the Aoki time, then Takahashi is the answer, or else Aoki is the answer. Now, how you can convert that? So, you are given that B minutes past A o'clock. So, it is like A hours has passed, and then after that B minutes is also passed. So converted into seconds, so A is the R, so A into 60 into 60 plus B into 60. Similarly, Aoki has got up at C o'clock and D passed, so C o'clock plus D plus 1 second. So C into 60 to 60 plus D into 60 plus 1, and whatever is the smaller, that's the answer. So I'll take it on the code part. So okay, my bad. So let us see the summations from here. So what you can directly see is that x, like the first time for the Takahashi, is A into 60 into 60 plus B into 60, and similarly C into 60 into 60 plus D into 60 plus 1, and whatever is the smallest, you have to just print out that. So that's the first problem. The second problem is you are given a sequence of length n consisting of the integers a1 till an. Similarly, find out the smallest non-negative integer that is not present in a1 till n. So because the constraints are very small, and just move down to some examples to understand it more clearly. So the non-negative integers start from 0. So as you can see that the given numbers that you have, 0 is present, 1 is present, 2 is present, 3 is present, 4. The smallest non-negative integer that is not present here, you have to just print that is the 4. Similarly from here, so we'll start from 0 always. So 0 is not there, so answer 0. So what you can actually do is that the best way possible is that I just thought that okay, I have to somehow find that what is the smallest number that is not present. So because the constraints are very small, you can either like somewhat make a hash map also, or like map or a set. Okay, so what you can actually do is that I just make a set because there are multiple occurrences also, and just insert all the numbers inside the set. So 0, 1, 2 and so on, so like whatever number is there. Now you have all the numbers. Now because the numbers are between 0 and 2000, obviously the smallest possible number will be from 0 till 2000 and let's say 5, because let's say that all the numbers are from 0 to 2000. So the next maximum number is 2001. Okay, so what's your approach here is that insert into a set, and then just do a for loop from 0 till 2000 and let's say 2, and just check that what is the smallest number that is not present inside the set. If it is not present, just print out that number, just break out of this one. That's the whole observation for this problem. Nothing much complicated. Let us move on to the second solution. So I'll post down all the links of the solutions, so don't worry. So second problem is that what I'm trying to do is that I will just make a set, insert all the elements in the set, then iterate from 0 till like I've just made 3000, whatever, you can just do to 2000 also. So just check that whether every number from 0 till the ith number is present inside the set. I just count that whether it is present. If it is present, just continue, like I will not do anything. If it is not present, you just print out that particular answer, like particular number, and just return, because you have found out the smallest non-negative integer that is not present inside the set. Cool. The third problem is, so you are given two sequences, each of length n, consisting of the integers a1 till an, like, and b1 till bn. So like two integer sequences are given here. Now determine that whether there is a sequence of length n that you can build such that it is a1 to ax that is satisfying both the conditions, that all the ith number will be from either ai or bi, and the difference between any two consecutive numbers is less than or equal to k. Can you build such sequence? That's the whole problem. So I'll tell you with the example. Let's say the first example eventually. So 5 and 4, so there are 5 numbers and the k is equal to 4. Now 4 means that every two consecutive numbers inside the sequence that you want to form is less than or equal to 4. So it is equal to 9, 8, 372, 372, and the next is 162, 162, 95. So 95. So let us build something like this. This is the A and this is the B. now you have to build somewhat a new sequence that is of length this only. So let's that this is the X sequence that is either AI or BI. That this is not divided by either AI or BI. So the number here can be either of both of them. So it can be either this number, or you can put this number, either of them. Now because you have two options, like it is somewhat like what you can say, like two options every point of time. So either every point it has two options, like it is like AI or BI. So the first position it is AI or BI, so A1 or B1. Then from A1 it is E2 or B2, and then from B1 it is also like A2 B2, and so on. So whenever I see some such type of trace, it's somewhat clear to me that it is some sort of either a greedy way, because like you can greedily put out positions, or it is a DP because tree is just telling me that. So okay, then what is the next optimal way to solve such problems? I thought to put greedy here, but greedy doesn't work. Why? Because let's say that if you choose 9 here, like let's say that if you choose any one of them, let's say that if you choose 1, then what is the next optimal way you want to, like what is the next you want to find out? Maybe it can happen that you choose the smaller one, okay, like whatever, like you just choose the smaller one, and then the other numbers as that the bigger numbers like 9 and 8 has a smaller difference. But if you choose 1, the difference between these two is like the difference between, if you just choose any one of them, if you just choose the first number to be 1, and then you have the two options to choose either this or this. Now if you choose 8, then also the difference between them is 7. If you choose 6, then also the difference between 5, but you have to k equal to 4, so you just said you will tell that it is not possible. But if you choose 9 and then 8, then it is also possible. So it is not somewhat a greedy approach. And then I thought, okay, just try to use some DP approach. Now for the DP approach, what you can actually do is that you have to just define out the state. Now the state is that, okay, I'm assuming like the DP state is that I'm trying to say that the DP of I, now it is I comma 0 and I comma 1. So DP of I comma, so let's say that DP of I, I'm just trying to say for DP of I only. So DP of I will just tell me that, okay, like if I'm like building out this series, and if I want to enter the ith character, and if it is A of I, okay, so if I'm building like a series like x1, x2, x3 and so on, so because I want to build some sequence of x, okay, that is this, and it is like somewhat, let's say I'm on the kth point. Now either I want to put AI on the next point, or I want to put BI, okay. So the best way possible is I want to check the last element. If this element which I'm putting AI is compatible with this x of k, like the last element that I've put, or either this element is compatible with that. So it is like I have two states. So it is like DP of I, comma, like there are two states. Okay, so the first state is like you can form a DP table like this. So the first value is always, so you can just store out Boolean values here, that whether putting out AI or BI here at any point is true, like it is correct or not. So I will like put it somewhat, let's say true for both of them first, because like putting the first element is obviously true. So DPI is just means that putting the ith, like A of I, A of 1 or B of 1 here, which is correct or not. Okay, this is correct. Now can I put A of 2 here? Now if I want to put A of 2 here, it just means that, okay, I want to put A of 2, then it is only like I have to satisfy two conditions. The first condition is that the series that is building from the back should be correct till now. So by correct I can check that it is true. If it is true, that means that the series that is building till now is true, because true just means ki like it is true that the x1, x1 till this is forming correctly. So I just check that the previous element is correct. And if it is correct, I am putting out A of the ith element. So A of I am putting here. And if I'm putting A of I in this sequence, and the above one is such that I have put So because if it is the above one means that I am putting a of somewhat a in this sequence. So if I'm putting a of I, in the previous state I have put in some a of I minus 1. So I put in that. So I just have to like ensure that the difference between these two is less than equal to k. If it is ensuring that, then I can put a of I and I can put true. Or else, if I cannot put true here, then I just want to insert. I just have to ensure that okay, maybe I want that this like the sequence that is forming of x of x1, x2, x3 till xk till this point is correct. Then I might not be putting a2, but maybe I want to put b2. Now if I want to put b2, I just have to ensure that the difference between the last character that I am putting in the first sequence. So if it is the first row means that I have the last character that is inserted is a of I minus 1. So if the difference between a of I minus 1 and b2 is less than equal to k, then I can ensure that okay, I want to insert b2. But because I want to insert b2 here, I will just insert true here. And similarly, I want to do the same thing for this row as well. And that's the overall problem. Like this is a DP state problem. I will take it down to code part, so it will become more clear to you. But that's the overall solution for this. So let us move on to solution part. So okay, C, yes. So what you can directly see, observe here is that I have made two vectors for A, like A and B, and C is the like DP table. So inserted all the elements, then mark the first element of both the tables as 1. Iterated over this sequences, like then checking that if the previous element is 1, okay, if the previous element is 1, I will mark the next element such that the difference between the current element and the next element is less than equal to k in the first row, then I will update the first row as 1. But if I'm putting a of I, like the next character is a of I, like the current element is of I, and the next element I want to insert is b of I, because of a of I is not like perfectly fitting out, then I will update like c of I plus 1, like the next row to be 1, not the first row, because I'm inserting b of I, not a of I. So okay, that's the whole thing. And then similarly for the next case also, that if okay, so it was according to the first row, now according to the second row is such that the b, like the last element, the I minus 1, I've inserted as b of I. So this row just means that this true means that I've inserted b of I minus 1 here. Now can I insert b here in the next case? So this last row just means that the element I have inserted till now is b, because in the last row. Okay, so if the last row, the second row is 1, then if the b of I minus b of I is equal to less than equal to k, I will insert b here in the second row, or else I will insert a in the first row, or like it is equal to 1. And in the end, when I have filled all the whole table, then if the last element is equal to 1, which means that I have successfully filled all the elements and it is turned out to be 1, then the answer is yes, or the answer is no. So it's some sort of a DB table. You have to just like learn about it, and that's all the problem. So the next problem is polynomial division. So I'll tell you in simple terms, like this whole seems very confusing to you, but you have seen polynomials. I'll just take it down to the first example, it will come over to you. So just don't read a problem statement, I'll tell you in simple terms. Just assume that you have two polynomials, that a and b. So there are two polynomials that is given to you. Now these are the lengths of the polynomial. So one means that there is a length of n minus 1, like n plus 1, sorry. So if this is n and m, so n is 1, so which means that there are two length polynomial. But two length polynomial, I means that just start filling out the polynomials from back. Okay, so let's say that it is, so I'll just tell you that 2 1, just erase out this whole part. So first polynomial is 2 1, and next is 12 14 8 2, 12 14 8 2. Now how to build out these polynomials? It is just that start from the 0. So this is the 0th element, this is the first element from the back. So it is x power 0. So x power 0 means that x into x power 0 plus 2 into x power 1 is just equal to 2x plus 1. This is the first polynomial. Okay, sorry. Okay, I have read actually. So this is 2. So the first element I've taken that this is x, this is x, this is okay, sorry, so this is the 0th element, sorry, this is the 0th element and this is the first element. So 0th element and first element. So what you can actually do is that, okay, my bad. So what you can actually do here is that this is 0, this is 1. So 2 into x power 0 plus 1 into x power 1, which is equal to x plus 2. That's the whole first thing. So like this same indexing, like 0, 1, 2, 3. So what is this polynomial? Can you tell me that? The polynomial is that going from that, 2 into x power 3 plus 8 into x power 2 plus 14 into x power 1 plus 12. That is the second polynomial. Cool. So this is A, this is B, and when you multiply these polynomials, as you have seen, like you have done polynomial multiplication like this, you will form a new polynomial like this. You just multiplication of these two polynomials. So the problem statement is just telling you that you have A and C, like the A polynomial and C polynomial that is given to you. You have to just find out the B polynomial. That's the whole thing. Now just take one example only. Let us take this example, and then it will become more clear to you. So I'll just take this example. Let us just clear out some spaces and then write down the polynomials. It will become more clear. Okay, so this is, let's write down the polynomial itself. So A is equal to x plus 2, B is equal to 2x square plus 4x plus 6, and this is C, that is 2x cube plus 8x square plus 14x plus 12. Now how do you get out these polynomials? We just do a cross multiplication of these polynomials, so you will directly just get them. But if you just remember, how do you like divide two polynomials? So you just have C and A, and if I just do C polynomial divided by A polynomial, then I will just get the answer. Now in 11th or 12th, like in high schools, you have done polynomial divisions. So the basic polynomial division way is that you'll just do like this. You have this polynomial just written like this, and this is the polynomial. So let's say that you have this polynomial at x plus 2. Now how you do like divide this polynomial? That's the very simple way. You just find out the closest multiple of this with this. You just divide out this part and this part. Okay, so it just turns out to 2x cube divided by x, so it turns out to 2x square. So you put 2x square here, and then you multiply the whole term with 2x square and put it here, so it becomes like 2x cube plus 4x square, and just minus out these terms. So this term becomes 0, and this becomes 4x square. And then you do the same thing, that you divide this new term, that is 4x square, divided by x, it becomes 4x. So it becomes 4. Now you again multiply 4x with this whole term, like this whole expression, that is 4x square plus 8x, and then it becomes 0, and then it becomes equal to 6x plus 12, and then you again do 6, and then it becomes 6x plus 12 becomes 0. So that is how you get the original polynomial, and that is what you're going to do here as well. Nothing much complicated. So what you'll do is that you will just do the same thing in the code part. So what you'll do, that you have this polynomial, you will first divide the first term, whatever you have, with this term, whatever you will get the value as of, you will multiply this value with the whole complete polynomial and subtract out the respective terms with the new polynomial that you will get like this, and then you will get the new polynomial, and then you will take the next term and do the same thing. That's it. Nothing much complicated, but I'll tell you how you can add on in the code part now. So let us go back. Let us take the T problem. So what we have done here is that we have built A, B and C. So what you can actually observe here is that in the expression itself, like the eighth term is from an till a of 0. Similarly, b term is from bm till b of 0. And the multiplication of a and b goes from c of n plus m. So like the multiplication, like, so it is like the n plus m, and there's a 0 term also. So the total length of this will become n plus m plus n plus m plus 1. Okay, so that's what we're going to take here. as well. So the C length is n plus m plus 1, B length is m plus 1, A length is n plus 1. We take the inputs of all the coefficients, then iterate from the back to front in the what you can say. So we are talking about the bth term. Okay, so what we'll talk about that in the bth sequence, we want to find out the value for the bth sequence, the AS sequence we have. So for the last coefficient of the bth term, what we'll do is that we'll first divide out the I plus 1 term with a of n, like the first term of the n. It's like the first term is the last term actually in the C, as you can see that it is reversed. So the last term divided by the complete term in C of I plus n. And when you get out, so the last term in A of n and the last term in the C Wali sequence. So the last term is, as you can see, that it is I is equal to m. So m plus n, that is the last term. So you divide out these terms. Whatever you get is B of I. And when you get this term, you multiply this B of I into all the terms in A of I and subtract it from A of I plus j. And then you'll keep on doing that until you like have done all the things, and you just print out the B of I polynomial. That's the whole problem. You just have to understand how you write down this whole thing, but in general it is not too much complicated to understand. Similarly, let us go down to the last problem, that is wrapping chocolates. So Takahashi has n pieces of chocolates, and the ith piece has a rectangle shape with a width of ai centimeters and a length of bi centimeters. So there are different chocolates, n chocolates, and the ith chocolate is of ai centimeter length and bi centimeter, like ai centimeter width and bi centimeter length. Similarly, he also has m boxes, and the ith box is that the shape of that is ci centimeter in width and di centimeter in length. Okay, so now you have to somehow place out, can you tell me that, can you place out these n chocolates in these m boxes? So obviously m will be greater than or equal to n, because they are like at least greater than or equal to n chocolates, but can you somehow fill out these chocolates in these boxes? Now it is somewhat a greedy approach. What you can actually do is that first sort out these chocolates as well as these boxes. Then let's say that if you sort out all of these chocolates by their width, okay, in the largest to the smallest length, now for every chocolate that you have all the boxes that can acquire that chocolate. Now what you can directly do in this problem is that, let's say you have a chocolate of w width and h height. Now if there are the bigger boxes like this, now what you can actually do is that you will just sort out all of these boxes w1 w2 by the width. Okay, now if I just find out all the boxes that have width greater than or equal to w, I will say that I can fill out these chocolates in any one of these boxes. Now what is the most optimal one you want to fill out? Because the width of all of these boxes is greater than w, I have this only the height constraint, and I just want to fill out in the box that is just greater than or equal to this height. Okay, I don't want to fill it in the very large box because the whole space will be empty, or I don't want to insert in a very small box because the length is very small even though the width is large. So I can only like fill it in the perfect box that is possible, that is the box that is just greater than or equal to w, like height, sorry, h, and the width is greater than w. So you just have to sort them and just quickly do that operation. And so for that, you can what you can do is that you have to first sort out the, I'll just show you in the code part, it will become more clear to you, but you just have to sort them according to their widths. And when you have these widths with you, you have to find out what all boxes have these widths greater than the width I want. So what I'm trying to do is that I have chocolates and boxes. I'll first insert all the chocolates and boxes inside there. I'll sort them by their widths, and then if the widths are same, we have to sort it by heights. So it is like from greater than to smallest, like it is a descending order. Then I have these multiset. I'll tell you why this multiset is used. So I will just iterate over these chocolates because I want to insert all the chocolate inside the boxes. So I will iterate over all the chocolates and chocolates. I'll just take the ith chocolate. Now I want to insert this chocolate. So what I'll do is that whatever boxes I have till now, because I just do is this qi over these boxes. What I'll do is that if the current box that it is there, if that height, like if the width of this box is greater than or equal to the width I want, then I will insert that box inside some multiset. Now I will insert by box because this just means that the width of this box is qualifying or greater than equal to the width of this chocolate, so I can fill out this box, like the chocolate inside this box. So I will just insert the height of that chocolate, not the width. So because the height is qualified enough. Now I have, so in the end of this while loop, I have all the boxes that are greater than equal to the width I want inside a multiset. Now I can do a lower bound on the multiset, so that I just want a box that is just greater than equal to the height I want. So I just want a height of y for the chocolate. I just find out the lower bound. If there is no such box that is available, I just return no, and I will just quit out all the other things because I just want to fill out all the chocolates. If any one of the chocolate doesn't fit, then I just like quit out. Else I'll just, because I filled that particular box with the particular width and height with this chocolate, so I'll just remove out this particular height because I'm just storing out this height in the multiset from this multiset, and just return out yes if I just perfectly fill out all the chocolates in that box. So that's the overall logic and code for the first 5 problems on the latest AtCoder beginner contest 245. So thank you for watching this video till the end. I'll see you next one. Till then, keep coding and bye.